wanted to demonstrate for you problem solving with this problem, talking about gold crystallizing in a face-centered cube. It tells me what the atomic radius is, and it wants to know the mass of 1 unit cell of gold. So let me get my pen working here. Forgot to do that first. Bear with me. All right. So what is a face-centered cube? Well, let's draw one out here. The length, the width, and the height are all the same. So I'm doing my best to draw that. I'm not an artist. But there is a cube, and we're going to imagine that the length, width, and height are all the same. And if it's face-centered, we will first, let me go ahead and get my bottom here. Okay, we know that there will be an atom at each corner. So that's 4, 5, 6, 7, and one in this back corner, 8 there. And then it is face-centered so that there will also be one on each face. Now each face is the same atom of gold, but I'm going to change the color just so that we can see the difference between the face ones. There's one on the top, there's one in the center of the bottom, there's one on the right, there's one in the center of the left, and there's one up here in the front, and there's one back there in the back, and it's kind of hard to see, but we'll kind of give it a dot back there. Okay, so top, bottom, left, right, front, back, those are all the faces. So we know that for the face atoms, okay, they are 1/2 in this unit cell and 1/2 in the neighbor. There are 6 faces, each is a half, so that is 3 atoms in that unit cell due to the face. And then we'll go back to the blue, and we've got for the corners, there are 8 corners, and each of those corners are shared by 8 unit cells, so it's only 1/8 in there, and that would be 1 for a total of 4 electrons. I mean 4, sorry, 4 atoms of gold. Now we want to know the mass of 1 unit cell. And if we venture way back to the first part of General Chemistry 1, we learned how to get to mass from moles, and we learned how to get, so we can go to mass, and we learned how to get to moles from atoms. Those are conversions that we learned how to do. So we will start with our 4 atoms. Get in the habit of not just writing atoms, but atoms of what? Gold. Then we can go from atoms to moles. And each mole is 6.022 times 10 to the 23rd atoms. And then we can go from moles to grams, and the molar mass of gold is 197 grams in a mole. Now before we put a number down, let's think about the magnitude of this number, just thinking about a unit cell. These unit cells are tiny. Look at that. This is the radius of an atom. Now these atoms are actually, and I'll just draw it with a dashed line, they're actually bumping up towards each other, okay? That's really how they look, but it's hard to see the cube if I drew it that way. So the radius is down here on a fraction of a nanometer. So if we consider this cube, we know it's very tiny, and we would expect it to have a tiny mass. We could also think of it this way. This is only 4 atoms, and each atom is minuscule, so we would expect it to be a tiny mass. And mathematically, we're dividing by a huge number, so we would expect it to be tiny. Students need to get in the habit of thinking about the logic of their answer, because I have seen students, they just punch it in their calculator wrong or use their calculator incorrectly, get a big number, and are okay with that. But there you go. That's the mass of 1 unit cell. And that gets us the first part. Now, very often, instead of asking what's the mass of a unit cell, the question will say, calculate the density of the unit cell. So, what else do you need in order to calculate the density? Density is mass, what? Well, it's divided by volume. And could we get the volume of the unit cell? What would we need? We would need the side length, and we would cube it, and that would get the volume. That's not the side length. But there are equations for each of our unit cells that get you the length of the edge based upon the radius of the atoms in it. And I have these really bumping up next to each other. That's not quite true because the face guys are getting in the way. These are actually bumping up against the face, and then the face is over here. So that's really what's bumping up towards each other. So one corner, the central face, and the other corner. So it kind of looks like this. And if you take those radii and do some mathematics with it, you will be able to determine that the edge length is the cube root of 8 times r. Now, that is true. We would be able to get the edge length and the volume and be able to get the density. I'm not going to do that in this problem, but you could. The next thing I want to ask you is this. Once you determine the density of this little bitty guy here, would it still be the same as the density of a big block of gold that maybe you'll find in Fort Knox? Okay, so we have this bar of gold, and it's so heavy it's hard to lift with 2 hands and stacked up in this vault. The question is, what would be the density of that guy? Would it be the same or would it be different? Well, it's got a larger volume, but it's also got a larger mass, so both of these are growing proportionally, and it would have exactly the same density. We use a term for that. Which of these 2 terms? Applies to a property that does not depend upon the amount? Well, that would be intensive. Intensive does not, I remember that because it has an N in it, does not depend upon the amount, and density would be an example of that.